plus of piecewise functions. Now the first slide is actually something we've done before, not with piecewise, but with other functions. How do you evaluate f of negative 2? Plane it for x, what if you only have a graph? You go to the x value of negative 2 and ask yourself, what is the y value? What is the y value when x is negative 2? What about f of 1? 1. Right here, we'll go with 1. Somewhere close to 1. F of 0. F of 2. Why not 3? Why not a little? It's an open dot, right? The closed-in dot is the actual value. So it can be a function. If both of them were closed in, we wouldn't have a function. Wouldn't have vertical lines. And the y value 5 is 3. Any questions? So we're going to learn how to graph a piecewise function. A piecewise function is 3 different, well in this case 3, could be as many or as few pieces as we want to talk about, but it's a function defined in pieces. This is actually very applicable in the real world. How many of you have ever gone and bought t-shirts for a club? Okay. What do you notice if you buy more t-shirts? They're cheaper per shirt. You have a totally different function after you get past a certain threshold. After you buy 10 shirts, then the price drops. So it's a piecewise function because after 10, there's a totally different price scale. So it's applicable in the real world. So we're going to learn how. Yeah, buying tickets to something if you buy more. And it's the reason that companies do that is because they have. When you're making a t-shirt design, it costs you a lot to make the screen print. After that, it gets a lot cheaper because you just print shirts. Then it's just the cost of the t-shirt, essentially. So they just have to make money off of the t-shirt after a while. But at the beginning, they've got to make money off of that design they made you. So that's why price goes down in bigger quantities. Okay, so I have 3 different functions here, but they are all one function, and that's a little strange for our brains to think of. But f of x is made up of 3 pieces. F of x is a function, and how this reads, f of x equals negative 2. If x is between 0 and 2. Does everyone see how it reads like that? Yes. F of x equals negative 2. Can I graph the line y equals negative 2? What does it look like? Horizontal line down negative 2. So if I were graphing the whole function y equals negative 2, it would look like that, right? But do I want the whole thing? Which part of it do I want? So I only want to graph the function between 0 and 2. I'm going to put a closed-in dot at 0 and an open circle at 2. Why would I do that? This one's less than or equal to, and this one's just less than. So I'm only graphing that part from 0 to 2. Does everyone see how that piecewise function reads? And what's the next piece? Y equals negative 4. Also a horizontal line. Does everyone agree? So where am I going to graph that horizontal line? From 2 to 4. So I'm going to go graph negative 4 from negative 2 to 4. Why did I do the filled-in dot on the left and the open dot on the right? Or equal to, and then just less than. Equal to is close enough. Any questions so far? different pieces of one function. Any questions about this one? Now we started with a really easy one to graph. We started with horizontal lines. We'll get a little bit more complex as we go. That's the equation.
Oh, that's...
So it's f of x equals -2, or y equals -2. And so that's a horizontal line. We will get some that aren't horizontal lines for other types of lines in a second, but we wanted it easy. Where? On this side? No. On this side, you'll have the inequality that tells you where to graph it, but on this side, it'll just be a function. Now, it will be typically a little bit more complicated than just a horizontal line. Maybe a regular line, but... So, this one is another one made up of mostly horizontal lines. We have one weird place we'll have to talk about. So I want to graph this piecewise function. See if you can do it. What did you do first? No. We do something with a 7. Okay, the top function is y equals 7. Does everyone agree? I put x equals 7. When x is less than -4. So I'm going to draw the horizontal line y equals 7. So what does that look like? Am I going to draw it all the way across the grid? Where am I going to draw it? When x is less than -4, so that's to the left of -4. -4 is here. So I'm going to put an open circle and draw a horizontal line to the left of -4. Everybody see how I got that? Any questions at this point? Stall and ask if you have any questions. We okay? Okay. The next one's weird because it says y equals 3 if x equals -4. What do you think that means? That's where you just plot a point. Why is that just a point? Because it's just at -4. So if y is 3 when x is -4, that's just a point. I'm going to graph a horizontal line, y equals -3, when x is between -4 and 2. Why did I do open circles on that? Oh, one of them should be filled in. Why did I do an open circle on the left? Because it's an or equal to, or not or equal to, and then on the right, sorry. Any questions about that part? So what does the last part say? Y equals -5, which is another horizontal line, right? From 2 on to infinity. So from 2 on, an open circle. The domain of this would actually be all real numbers if you were to have to find it, because I always touch it. So it is a book page, but I'm giving you a worksheet. It is actually a book page. The range would be pretty yucky on this. It would actually be y would be -5, -3, 3, and 7. Like it would just be those data points. That's not how we different. This particular one's a strange range because it's just 4 points. But since you have. Okay, this one's a little different. Because now the function is not just a horizontal line. The function at the top is y equals -x. And the function at the bottom is y equals 2/3 x minus 4. Are both of those functions things we can graph? Yes. Now you have two options on how to graph a piecewise. You can graph the whole thing and then erase back. A lot of you will like doing that because then you could just use the y-intercept and the slope. The other option is to just graph the 2 points you need, and I'll kind of show you both options. I'll do one side one way and the other side the other way, and you can decide which way you like better. Okay, so I'm going to plot the first one. It's y equals -x. If x is less than or equal to 3. That's what that part says. Well, how do I graph the line y equals -x? There's actually a lot of different ways we can graph lines, but what's one way? Slope is -1. What's the y-intercept? 0. So I can plot the y-intercept, and I can plot the slope, and I can draw the line. Correct? So I'm going to do that. The y-intercept is 0. Slope is -1, so I could go rise 1, left 1, right? Or you could go down on the right one. And you could do that as many times as you want. And so we would draw that line. I drew the whole thing. Is that really what I want? Which part of that line do I want? From -infinity up to 3. So don't I want to stop it here? So this, if you do it this way, you will need an eraser that works. Because you will have to pick up your eraser and go, okay, I've graphed the whole thing, but I didn't want this part. I wanted it just to stop at 3 with a filled in dot. Any questions about how I plotted the left side? I can do that exact same approach on the right hand side. And then erase back. But I am going to show you another option for the right-hand side. You can choose later which way you like better. -1. So, on the right-hand side, I know that I can graph a line by doing the y-intercept and slope. But couldn't I also just graph a line by doing 2 points? Or doing a point and a slope? Right? But instead of going all the way back over to the y-intercept, erase. Those of you who hate erasing, you wouldn't have to erase with this option. But just to let you know, would it have been okay if I used the y-intercept before and just erase? Why did I get a slip? Well, we have to have the equation. Oh. And that is the correct equation. But I only want that line from here to here. Again, we could have graphed the whole thing and then gone, oh, I don't want this part, and erased it. And so that's a perfectly good way to do it, and you are welcome to do it that way. So you have options. You can either plot a point and then graph a line, or you can use the silk command to erase. So that's two options for you. Pick whichever one you like better. No. So that top one is the equation. Y equals negative x plus 0. Okay. How do you graph a line? So y-intercept. And y-intercept is and the slope is -1. And so the y-intercept is not -1. Now you could also point plot. You could plug in. If I do plug in 0, correct? What I get. So at 0, you can 0. You can point plot this one. Any questions about that one? This one is a little bit more complex because it had lines and stuff, but slanted lines instead of horizontal lines. Okay. We will probably want our calculator's help on this one. Would you agree? Why would we probably want our calculator's help? X squared minus 4. Do you know what that looks like? Kind of. You just graphed quadratics yesterday, so kind of. But is it one that we are not as familiar with? So pick up your calculator for me and graph x squared minus 4. Trace along it to get accurate points. It is a quadratic. On this one, because I am less familiar with it, I'm going to graph the whole thing and use the erase option. But you could just graph a piece if you can see that in your head. If you graph this in your calculator, and again, be accurate on the points. You can use your trace button or you can use your table to get a few points. Does everyone agree that it looks like this? That is the graph of x squared minus 4. And I just got that off of my calculator screen. Do I want the whole piece of the whole graph? Which part do I want? One where x is less than or equal to -1. So what am I going to do? I'm going to erase. Which side am I going to erase? The right-hand side. All the way back to when x is -1. Right there. Am I okay with my filled-in dot that I have sitting there? Yes. If it's not, I erase it. Is it important that this point is the right place? So don't just, I see some of you sketch quadratics. Just don't do that. Go and find the points. Use your calculator to do it, but get an accurate sketch. You can. If you plug in -1 into that quadratic, you would get -3. That would. Yes, that would kind of be that second option. You know what I mean? Plot points. That works. On the right-hand side, I'm going to graph the line 2x minus 1. Am I going too fast? 2. So I'm going to go rise 2, run 1. Now, I've only graphed the side on the right. Do I need to go left a little bit? A little bit. What do I need to go all the way to? -1. So I do need to continue my line backwards to -2. So you could go down to left. Well, it actually falls on the same dot, doesn't it? But it falls on the same dot as. So actually, it's going to be hard to tell even because I'm going to have an open dot on top of a closed dot, right? It kind of filled in the dot. Makes this what's known as a continuous function because they connect. But it happens sometimes where they do that. Any questions about how I graphed that? Okay. Evaluate the function. Now, I could graph them and do what I did on the bell ring. I would argue that that's a waste of my time. Because how do you normally do f of -5? You plug in -5 for x. The only problem is there's never two answers to f of -5. There's only one answer. So where will I plug in f of -5? And why? Where do I plug that one in at and why? Would it be like the second part? X has to be greater than -3. What you said is right, but you answered wrong. Is -5 greater than -3? No. Okay. -5 is less than -3, right? So perfect explanation. Sorry. No, you're good. You're good. Yes, you did. That is perfect. Sort of. Okay. Close. So -5 is less than -3, right? So isn't that this piece of the function? So when you see that, forget the other piece ever existed. F of -5. And if I were to graph this, wouldn't -5 fall on that top piece? So I'm going to plug the -5 into that top piece. On this test, you will get this question completely wrong if you put two answers. Mental note that. There's not two answers to the question. You have to know which piece to plug into. You might start that in your notes. It's one answer. 25 minus 3 is... That's right. Where will I plug the -3 in? 22. Do you see how I got that? Why will you plug it into the second equation? It's or equal to 3, right? Or -3. So -3 is equal to -3, so that goes in the bottom equation. And what about f of 10? The second equation. Does everyone see how we're getting that? I want to stall for a second. Is anyone lost on why I know where to plug it in? Yes. So, if I were to graph this, I would get this to the left of -3. I would get the quadratic. Right? To the right of -3, I would get the 1. Well, here is -5. To the left, so it goes in that. And where is -3? Well, it's right on the line. It's that one. And then where is 10? To the right, so it goes in the line. Yeah, did that picture out? 2 more. I'm going to do one more example, but this is your homework. That is written at the top of it, so you don't have to write that down. This worksheet pretty much just gives you grid paper to answer the questions that need a grid. And you'll see there's some directions questions on there, like on number 11, it says don't do part B, so you don't have to do part B on 11. So just read these, answer all of the blanks. I believe there's a spot for every problem up there at the top. Okay? Got one more example and we will be done. F of negative 3. Where will I plug in negative 3? Where is negative 3? Less than 2, right? To the left of 2. So, negative 3 squared is 9. What? No. Because if it's truly a function, which piecewise functions are, there will never be an overlap. What James keeps saying is if it gets on top, then you would have a function. F of 0. Where is 0? Still less than 2, right? Where is 2? It equals 2. Well, there's nothing I can plug in, but isn't that 3 all the time? Horizontal line 3. So y is 3 when x is 2. And f of 5. The last equation. It is important that there is a negative in front of that. That negative is outside of the parentheses. So what is negative 5? 5 in parentheses squared. Negative. Okay. Any questions about today? Have y'all seen piecewise in the ACT before? Oh, another skill. See, we're chipping away. We will talk about